step we're going to look at is solution by substitution. So we're going to continue with the simultaneous linear equations, but we're going to solve them using substitution. Now, what we were doing in this one, so you see that the method of the solution by substitution is used when at least one equation is given with either an x or a y as the subject as the formula. So we substitute the expression for the variable into the other equation. So the steps for doing this one is you solve for x or y in one equation. So the equation could look like this. So you're solving for x or y, you plug the other equation in and solve it. Then from that you get your answer and then you can solve for the other variable. So what we're going to do, we're going to have a look at this question. So we've got y is equal to x plus 1. And what we're going to do, we're going to call this 1. So that's number 1. Then you've got 2x plus 3y equals 21. We're going to call that 2. Now, because we want to find a certain, we want to find x or y, I think we could probably start by finding x. Because with this one, you've already got y is equal to x plus 2, so we've sort of got something to work with already. So what we do with this one, you bring this second equation down. So you have 2x plus 3, but instead of putting the y, we now take these values because y is equal to x plus 2. So in a bracket, x plus 2 is equal to 21. So what we do from here, we've got the 2x we already had. We expand the bracket here and here. So 3 times x, so positive 3 times positive x is positive 3x. 3 times 2, both being positive, will give us 6. And we have 21. What we do from here, you collect your like terms, so that becomes 5x, because 3x and 2x are 5x, plus 6, leaves you with 21. Alright, so we're trying to get x by itself here. So there's one step we can do first here. We can look at this 6. Now, to eliminate that, we need to take 6. But if we do it there, we must also do it on the other side. So, to leave that as 5x, because we've eliminated that, 21 take 6 gives us 15. Now, to get x by itself, 5x is the same as 5 times x, so the opposite would be to divide. Divide both sides. 5 divided by 5 leaves you with 1x. 15 divided by 5 is 3. So we now know that x is 3. So what we can do with that then, is we can then plug that back into part 1. So when we had y is equal to x plus 2, we can now plug in the 3 instead of x. So you've got 3 plus 2, leaving you with y is equal to 5. So we've now got our intersection of 3 on x, 5 on y. So if we were to do that graphically like we've done previously, we'd get the same result. But we've just done it in a different way now, so by substituting one into the other. Now with this one, as you can see, we've got x is equal to y times, take 3, sorry. It's a little bit different, sorry, not that one, to this one here. So we had y equals x plus 2. So what we're going to do is we'll look at this one because it's a little bit different. So, because we've got 5x, so we've got 5x, but we've been told that x is equal to y take 3. So instead of x, we do y take 3. Take your 2y is equal to 9. So same thing, expand your brackets, so this one and then this one. So 5 times y, 5y. Negative and a positive gives us a negative. 5 times 3 is 15. Take your 2y is equal to 9. So once again, collecting like terms, those two. So 5y take 2y will give me 3y. Take 15, being 9. So I'm going to try and get y by itself. Now, so to eliminate that one, we need to add 15 there, which means we also add 15 to the other side, which will give us an answer of 3y, 9 plus 15 being 24. Want to get y by itself, so we divide by 3 on both sides, leaving us with y, because they cancel. 24 divided by 3, should be getting 8 for that one. So we've got y is 8. So now we go back to our number 1. Sorry, I should have done that first. We go back to 1, and to find x, we substitute 8 in instead of y. So we'll put that in, show the steps. 8, take 3. So x for this one will be 5. So our intersect, so I can spell it, will be 5, 8. So there's only something a little bit different with that one, was that we did it the other way around. Alright, so now the next step, we'll go a little bit further. Now we're going to start getting some ones where we look at, where we've got a fraction, for example. Now, they're not that much different, but there's a few little things that we need to keep in mind to remember to do these ones. Okay, so we'll still label them. We've got 1 and 2. Now, y is equal to half of x plus 5. We've got y here, so we'll substitute that value in for that. Okay, so we've got 3x plus the 4. Instead of y, we've got half of x plus 5 is equal to 5. So what we do from here, obviously, we're going to need to expand. Now, we're going to need to remember what happens when we multiply fractions, for example. So if I've got 4 times a half, it's nice and easy because we know if we times 4 by half, we should be half of 4, which would be 2. But if it was a more complicated fraction, so if we had 4 times 5 over 6, for example, it's not as easy to remember how to do these, but we need to remember what we're doing. So 4 is the same as 4 over 1. When we multiply fractions, it's 4 times 5, we multiply the denominators. So you have 20, and 1 times 6 being 6, and then you can obviously simplify that down. So, but in the case of the scenario that we've got here, with our equations that we've currently got, we have 4 over 1, which will give us 4 over 2, which is then 2. So we'd have 3x plus, now you could have it as 4 over 2x or 2x, plus your 5 is equal to, sorry, not 5, easy mistake to make there, guys. So 2x, make sure you multiply 4 and 5, which is 20, and 5. So once again, collect your like terms, 5x plus 20 is equal to 5. We're going to get x by itself, so we're going to get rid of this one by doing negative 20, or take 20, sorry. So we have 5x, 5 take 20 will give us a negative 15. Now we're going to divide both sides by 5, so x will be alone. Sorry, that didn't work. Let's put that one in. Negative 15 divided by 5 is negative 3. So that one worked nicely. Now, so that there, this answer will get subbed back into this one. So we've got y is equal to half of x. So half of x is 3 plus the 5. Now, what we've got here, now half of 3, which is half of 3 over 1. So 1, so you have your 3 over 2 plus 5. And sorry, that's a negative, so that'll be negative. So that one will be negative. So you've got negative 3 over 2 plus 5. Now, we need to remember how to add, subtract fractions in this case, without having to use the calculator. So what we need to do, this is currently 5 over 1. Yeah? So, what we actually do with that one is we make the denominators the same. So if I've got 2, and I need to add in here, so 2, obviously to make that one 2, this needs to change. So for that to go to 5 over 1 to something over 2, it went up by it went up by 2. So 5 is 10. So you've got negative 3 plus 10, which will give us negative 7 over 2, which is actually y. So negative 7 over 2 will give us a negative. We've got 3 lots of 2 and 1 left over. Okay, so when it comes to your fractions, you need to make sure you remember the steps we take when adding, subtracting, multiplying, dividing fractions, for example, in this case. Alright, good luck.